In the 1500s, solving a cubic equation was one of the greatest open problems in mathematics. Linear equations, easy. Quadratics, done that. But cubics, equations with x to the power of 3, the solution had eluded mathematicians for centuries. Then, in the 1500s, an Italian mathematician named Niccolò Tartaglia made a bold and unexpected move that changed everything. But there's something to note before we dive into the equation. Mathematicians back then did not have algebraic symbols to notate operations. Instead, they stated their proofs in the form of essays. Tartaglia wrote his solution in the form of a poem. So, all that you see in this video is an interpretation of his logic translated into our modern notation. It all began with a depressed cubic, or a cubic equation without the x squared term. Instead of trying to solve the cubic directly, Tartaglia assumed something unexpected. He supposed that the solution could be written as the sum of two numbers, a and b. If you cube both sides, you get x cubed equals a plus b cubed, which we can expand. And after expanding, we have this. Since a plus b is just x, we can simplify this even further. And now we can substitute this back into the original cubic, where something incredible happens. Right now, a and b can be any number. So if we choose a and b just right, we can make this middle part of the equation disappear. We want 3ab plus p to be 0. If we simplify this, then we know that a times b must equal negative p over 3. In the original equation, the x terms cancel completely, and that leaves us with this. Instead of solving one cubic equation, we've now reduced this into solving a system. Now, you may be thinking we just made everything worse. We now have two cubes. But here's where everything comes together. We just need to make one more substitution. Let's set u to a cubed and v to b cubed. The sum of these two numbers equals q, and if we cube the second equation, we see that u times v equals negative p over 3 cubed. Now we have the sum and product of u and v. Using the sum and product, we know that we can rewrite this as a quadratic with u and v as the roots. So secretly, Tartaglia turned a cubic into a quadratic, and they knew how to solve that. We do too. The quadratic formula. We can substitute in and simplify. And once we do that, we've solved for u and v because u and v are the roots. Now that we know u and v, we can find a and b. And now that we know a and b, we can solve for x. All of that combines to form this monstrous equation. And that is how Tartaglia dismantled the cubic. But here's the twist. Sometimes, when you use this formula, something strange happens. Even when the cubic has a perfectly real solution, sometimes the formula may force you to take the square root of a negative number. In Tartaglia's time, that was thought to be nonsense. Even though Tartaglia found a solution to the cubic, his discovery was just the beginning. It introduced a number that forced mathematics to expand. And if you want to find out how this strange square root reshaped all of math, check out this video on imaginary numbers and subscribe.